here now. Sorry, it took me just a second to copy and paste it. So this is what came in the email from Mr. Kibbe. So this was like decided on by a leadership group within the staff. I'm not a part of that, so I can't tell you exactly what the decisions were. But the decision was made that they split up, and I think we kind of did this last year, but that finals time would start November 8th. That's next Thursday. And would go Thursday, Friday, Monday, Tuesday, Wednesday, Thursday, and we do not have school on Friday. That's the records day when you guys are off and we get to stay here and make sure that all of our grades are, tied up in a nice neat bow before we move on. And second trimester starts that next Monday, okay? So the way that it's structured is that science is allowed to give tests only on November 8th and November 13th. Those are the only 2 days that we're allowed to give tests. For whatever reason, that's just the way the decision was made. Does that make sense? So thinking ahead and thinking about what our plan is, I'm going to go ahead and pace ourselves to be ready to do our test over this material on the 8th, our quiz, just a quiz over this material, okay? And I've kind of paced it out so that I know what we can get to, and I think we will be able to get there. I know that the homework you worked on today or for today was a little funny, but honestly, it's because we're just kind of tiptoeing into things, and the questions at the end of a chapter always kind of assume you know a lot more than, you know what I mean? So I tried to pick the right ones, but again, we'll get through it, okay? The reason I wanted to do that was to give us a little bit of wiggle room for that next Tuesday if we need to do any reassessment or any second opportunities for understanding so that I can give you that chance, okay? So I can't adjust this because I was told that as a class, I am not allowed to assess on these 2 days or these 2 days in class. Now, if you happen to be involved in something like the play, or you happen to be involved in something that makes Thursday, November 8th insane for you, then let's talk, okay? And let's figure out a solution, whether that is moving it down to Friday or whatever we need to do so that you feel good. Do you know what I'm saying? But I can't do that. I'm not going to wholesale make that decision for the entire class. Does that seem fair? Okay, so I started today trying to articulate, what the standards will be. There will be a couple of them. I don't have them exactly written out yet because I'm still working on the wording, but they will both kind of cover Newton's first and second law. You're like, I don't know what that is yet. I say, that's okay, we're going to find out today, okay? But it involves the forces business that we've been talking about for the last few days. It involves the free body diagram stuff that we've been talking about. So that's what's going to be assessed on the 8th. We'll do a little lab in here to kind of make sure things are really making sense, because even though the trimester ends, physics doesn't end, right? So we'll keep, pushing on. And so we'll kind of do some other stuff in here as well. Does that make sense to everybody? Does that seem fair? Okay. If you have specific questions, please let me know. Okay. During Liberty Time the last couple of days, I've been pretty busy having people come in to do reassessments and that sort of thing, which has been fantastic. If you have not yet made a plan with me, one-on-one, Miss Carver, I'm going to come in during this time to do those reassessments, please do that today or tomorrow at the latest. I don't want that dragging out because on November 16th, I have to have all of the grades done. And I don't want you to be doing it on Wednesday or Thursday of that week because I don't have time for that, right? Because I also have to plan for next try. So I want it to be done. I want your plan Friday at the latest, okay? Don't tell me next Wednesday, oh, Miss Garbling, I'm just not doing really well in this class. Because at that point, we've had lots of chances. Yeah?
What would you say is the hardest try in physics?
Probably this one. I mean, let me tell you, I would say for two reasons. First of all, this is the most computationally heavy, the most mathematically heavy one. So that's one reason. The other reason I would say is just because you're just kind of getting used to it, right? You're getting used to me and you're getting used to how this kind of thinking is structured. So first trimester is very math heavy, as you've noticed, right? It is very kind of problem solving heavy. Second trimester, there's a decent amount, you can put your hand down, but I'll call on you in just a second. Second trimester, it focuses, there is a lot of problem solving, But in my opinion and experience, it's more straightforward. It's a little more intuitive. And then third trimester is honestly for most physics students kind of like the most, I don't want to say enjoyable because I think it's all fun, but like we do a lot of waves and we do a lot of light and we do a lot of sound. So it's kind of different kinds of physics than the like motion stuff that we've been focused on. Does that make sense? Yeah. So you've gotten through most of the thick of it, I would say. Yeah. And now you know kind of how I work and you're getting a handle on it. So yeah.
Will there be much more things unexcluded from the gradebook?
What do you mean by that?
Like, is there still stuff in the gradebook that is excluded that you're going to unexclude and keep like
labs, like they're excluded?
There's only like 4.
Yeah. So the lab standard I have not cleaned up yet.
Okay.
And I'm hoping to do that as soon as I can. You know what I'm saying? But the other 4 standards, the big standards we've done so far, right? Those should be, unless you're planning to retake stuff, those should be set at this point.
Okay.
Does that make sense? And then we'll have one more standard that will go in there. It'll be an 8-point standard, just like we did before. Yeah. So there'll be one more 8-point standard, and then any retake stuff that you've done, and then the lab.
So all the labs would be like have their own standard.
Yes.
Together.
Yeah. And I would imagine that unless you have not turned things in, that's only going to help your grade, right? Like you should have a pretty solid grade. Yeah.
And we should have already done the break card once you got that lab right away, right?
I mean, if you still have it, just give it to me. Like I would rather have stuff in there, honestly. Like that's, yeah. So yes, you should have, but I'm not going to freak out. I would rather get stuff done. Yeah. Logistical questions beyond that? Okay. Let's move on and do some physics then. But please keep asking questions if there's logistical stuff that you're not sure about. I wanted to start today going over homework. Why don't you guys go grab books so we can talk about it? And then we'll go through anything you want to go through. I'm super happy to spend lots of time or just a little time. Whatever works for you is fine with me. All right. So I guess first question, are there questions on the homework? What's that? Sure, for sure. Which one do you want to start with, Stella?
10.
Number 10, sure. Start at the beginning, right? Question 10. Oh, yeah. So we're on page 146. If you're not there, you can join us. Page 146, number 10, says 4 forces act on a hot air balloon shown from the side in the figure below. Find the magnitude and direction of the resultant force on the balloon. So they're using some words that maybe I haven't used quite in the same way before, but I think we can do it. So you've got your balloon, and there are 4 forces. I'm just copying this down because my picture is awesome here, right? 4, 0, 5, 0. We've got 5, 1, 2, 0. We've got 9, 5, 0. And 1, 5, 2, 0. It says, find the magnitude. What does magnitude mean?
Entire thing.
Length, size, something like that. You want to find the size and the direction of the resultant force. We've seen the word resultant, but not in the context of forces. What do you think that the resultant force might mean? What did a resultant vector mean? We talked about that. It was like the hypotenuse, right? Like, yeah, so like add it up and figure out what's going on. So this is kind of like a 2-dimensional tug of war situation. You've got one force pulling down and one force pushing up. If you look just at the y direction, the down and up, which one's going to win, the up or the down? The up. How do you know it's the up? Right? How much is it going to win by? Can you tell me? 5120 and 4050?
1,070.
So it's going to, what did you say? 1070. 1017. I can't talk. 1070. Okay, so that's going to be the resultant of the up and down part. Talk to me about the left and right part. Who's going to win, left or right? Left is going to win. Woo. Left is going to win. So how much is it going to win by? 500 what?
70.
Okay. So the resultant is just going to be from 1 to there, right? So there's a little bit like the total is going to pull up some and it's going to pull to the left some. And we can figure out exactly how much total by going from the tail of the first to the head of the last. It's like you've done this before. It's kind of sneaky, right? It's probably pretty good that we spent the last unit doing the vector stuff, since this goofy vector stuff just doesn't seem to go away. Can you find the resultant? Either yes or no. Depends on how confident you felt about all the other stuff. But you can hop up and get a calculator, or you can pull a calculator out of your bag. Can you find the magnitude? That's the size. Pythagorean theorem is your friend. Yay! I've got 2 calculators up here somehow. Do you need a calculator, let's say? There you go. You're so welcome. My pleasure. If you're feeling like, wow, I thought I was done with that from last chapter. Darn it. Yeah, part of it is that we build on it, right? And part of it is, if you're still not feeling great, let's get you feeling great so that you can assess this again and we can make sure that you really, really do understand it. So you do 750, or excuse me, 570, mixing up my numbers there, plus, excuse me, 570 squared plus 1070 squared. Square root that answer. Oops. How are we doing? What did we get? 12 what?
12.35.
12.35. Do you guys agree with her?
Yeah.
Awesome. 12.35 are newtons. And so that's the magnitude that we have to do the direction to, don't we? Yay! Tangent. Let's do it. This one's kind of funny because we're talking about up and stuff. So either you're going, yes, I know how to do this because I just did this or I've done this a little bit ago, or you're saying, how do I do this? So we're going to choose the angle that's next to the kind of like the origin, right, the original part, and then we're going to do, we know these two for sure with no approximation. The 570 is the what of that triangle? Opposite. The 1070 is the adjacent side. Opposite and adjacent are involved in which trig function? Tangent. So just to be clear, in case we were unsure before, we're going to say the tangent of theta is opposite, which is 570, divided by adjacent, which is 1070. We want to get theta, which means we need to do the inverse or the opposite of the tangent, right? We're undoing that. I'm super excited that there are a lot of you that I feel like when we first started this, we're like, I don't have any idea what's going on. And now you're like, oh yeah, I kind of get it. That's super exciting, you guys. Learning is taking place. And if you're not feeling that way yet, know that we can still get you there, okay? If this is confusing to you, make a point to come in and talk to me sometime. I'm here always. I go home sometimes, but I'm available. And if you want me here, you just let me know when, and I can make a point to do it. I'm here for you, but you got to advocate for yourself too. We were just talking at lunch today, because teachers talk about like students in general during lunch, and we were talking about how it's important for us to like help students. And my strong feeling, friends, once you're in physics, is that you've got to know how to advocate for yourselves. And I'll come hunt you down if I have to. But I want you to be able to do this, like do this conversation. Advocate, advocate. Inverse tan of 570 over 1070, what'd you get? 28? Okay, and then, oh my gosh, there's no north, south, east, and west in this one, huh? How might we describe this? Like, it's a good question because I only know how to do it with north, south, east, and west. So which way do we start facing?
North.
Well, it's not really north because the balloon is going up. So up. And which way are we turning? Left of up? Sure. Sure, it's left of up. That sounds good. I will tell you in the book, the answer they wrote was 62 degrees. So the complement of this, above the 1524. So you could also say like to the left of the, whatever. It's the same kind of thing. I would just say left of up. Are you going to have something like this on a quiz, like this business here? No. It's just the idea and the process of doing the tug of war. That's what was important for me in this question. Okay, that's what was important. What else do you want to talk about? Number 11. Oh, yeah. 2 lifeguards pull on ropes attached to a raft. They pull the same direction, and the raft experiences a net force of 334 to the right. They pull in opposite direction, and the raft experiences a net force of 106 to the left. Draw a free body diagram representing the raft in each situation. Find the force exerted by each lifeguard. Oh, interesting. So I was really excited about this one because of the free body diagram. So there's a raft. Look at it. It's so cool. In the first case, you've got 2 lifeguards and they're pulling in the same direction. So how would we do that? Force of lifeguard 1 on the raft. Force of lifeguard 2 on the raft. They're both pulling in the same direction. What about in the other case? What would the picture look like? If they pull in opposite directions, blah, blah, blah. Talk to your table mates. What's it going to look like? Lifeguard. Lifeguard 1, lifeguard 2. I'm just lazy. You can write out lifeguard if you want. I'm just lazy.
I don't know if it was like an arrow thing.
Oh, no. Yeah, it's kind of, that's Trixie. I apologize. Not intended to be that confusing. I apologize. Thanks for asking, too. In situation 2, what does it look like?
I wrote one is, so I put one going left, which is X, and then one going right, which is Y.
Sure.
And then I wrote down 2 equations.
Oh, he's getting ahead of us, too. Lifeguard 1 on the raft. Oops, force of lifeguard 2 on the raft. Is that okay? Yeah. Only reason that I know that, probably the only reason that Isaac knew that, but maybe you've got some intuition that is stronger than mine. It just says, if they pull in the same direction, blah, blah, blah. And then the second part says, if they pull in opposite directions, blah, blah, blah. So, same direction, blah, blah, blah. Opposite directions, blah, blah, blah. Okay? How are we doing? Are we okay? So now we can write down some F-net equations. We talked about F-net equations a little bit. And I will tell you one of the big standards that I was kind of crafting, but I haven't like fixed perfectly, so I haven't written out for you, is writing out a free body diagram. Oops, sorry. Go away. We don't need you. No. I do not want to save changes. No, thank you. Is drawing a free body diagram and then writing an F net equation. So let's write the F net equation. Here it comes. F net. In this case, I'm going to just call it the force 1 plus force 2 because I'm lazy. Lazy, sorry. They pull in the same direction. The raft experiences a net force of 334 newtons. Is that what your first equation looked like as well?
Yeah.
I mean, you used X's and Y's.
X plus Y.
Yeah, that's cool too. Yeah.
But on the quiz, you want us to do.
I mean, if you write F net, if you have labeled these, well, actually, I want you to write force of blank on blank. But if you then tell me that that's X, and you tell me that this one's Y, and then you write X and Y there, I'm cool with that. Yeah. Yeah. And then this other one over here, F net. It's still F1 plus F2, but what's different in this case? Besides the fact that it adds up to 106. What's different in this case? They're not pulling the same direction. How would I note that in an F net equation? One of them has to be negative. Given that we called both of these two positive, I'm going to call this one positive and call F2 negative. But to be honest, it doesn't really matter, does it? Doesn't really matter. But in this case, I'm just going to go ahead and call F2 negative just because that's how it is in my picture. Okay. This is the most important part of the question to me. We can do the other part. We've got 2 equations and 2 unknowns. That's not super hard to do. We can plug it in and solve it. Would you like to go through that part? I'm not going to test you over that part. But if you'd like to, we can go over it. Yes? No? Yes? Okay, we'll do it. Awesome. So this is just math skills. Math skills are important. I believe in them. Okay? I'm going to make a suggestion that we solve this one for F1 and then plug it in. Plug into the other equation. When you're in, I think it's algebra 2, you learn all kinds of different ways to solve systems of equations. There are lots of them. You can graph it. You can do all kinds of fun things. But I'm just going to do it this way because, it seems pretty simple to me. So I'm going to add the F2 to both sides. So I get F1 is equal to 106 plus F2. The deep, dark reason that I did that, just getting inside the mathematician's brain, is that this one is negative and I don't like negative numbers when I can avoid them. So by adding it to this side, now everything's positive. Positive things make us happy, right? Inherently. So now I'm going to take this thing that says F1 and I'm going to plug it in right over here. Is that okay with everybody? Not doing anything too wild and crazy, I hope. If you feel like that, then I don't want you to worry about this. Again, I'm not going to test you over this kind of thing. This is just some math skills, but they're good math skills. So I'm going to take this F1 business and I'm going to plug it in right there. So instead of writing F1, I'm going to write 106 plus F2. So that's that part. Okay. Plus F2 equals 334 newtons. Now I've got one unknown. How many F2s do I have, guys? 2 of them? So I've got 106 plus 2 F2s equals 334. Want to get F2 all by itself. Subtract 106 on both sides. Subtract 106 on both sides. 2F2 is equal to, I have to do some borrowing here. So it's going to be what? 8, 2, 1, 2, 228. Did I do that right? Check my subtraction. Okay, awesome. I don't do mental math well in front of people. I've learned that about myself. But I can do this mental math. I'm going to divide by 2. I can divide by 2. I can do that one without any, now I say that and I'm totally going to mess it up. 114 newtons. Is that okay? 114. Now that I know that one, I can plug that in here and then I can figure out what that one's going to be. It's going to be what? 220? Eh?
So
Well, algebra 2 skills here. Yeah.
so when we got to the second equation, that's the one that we
Here?
that we need to focus on. No. Right there, yeah. That negative. That's one that we're going to be like that.
You need to know how to write these FNet equations.
So
yes.
After the FNet equations, we don't need to know how to do any of that math.
So let me clarify, because I want to make sure that I'm stating this clearly. So you will absolutely need to know how to draw a free body diagram. You will absolutely need to know how to do FNet equations. We are going to do things with the FNet equations still, like we did yesterday. But this, like plugging things into like this, you don't need to do. Like from here down in this problem in particular, it's just algebra. That's not what I'm concerned about. Is that okay? All right. 12, 15, or 27, any of those you want to talk about? Or should we move on? I'm super happy to go through them if you want.
15, like a thinker one, more than a math.
15 is a thinker one, yes.
Can we just talk about
We can, yeah. 15 says an astronaut on the moon has a 110 kilogram crate and a 230 kilogram crate. How do the forces required to lift the crates up compare to that required to lift them up on Earth? Okay. So I've got a box, or I've got a frog, or I've got a whatever, right? How does the mass of the crate compare on Earth to the mass on the moon? Same, right? Same mass because the same amount of stuff, right? Same mass, same amount of stuff. That's true on the moon or on Earth. But what's different on the moon? The weight is different, right? And the weight is what is required to lift them up. So if I have a little crate, right? If I'm going to lift it up, if I'm applying a force, I have to apply a force that's the same, right, as the force down, right? That's when it's going to be in equilibrium. Are you with me there? We talked about this a little bit. So it's like my hand is like supplying the normal force. If I've got something that weighs more, it's got more of a force of in this case, of the Earth on the box, I have to push harder than if I go to the moon, and now it has less force down, so I have to apply a smaller force up. Does that make sense?
Yes.
Yeah. And why is the weight smaller on the moon than it is on the Earth? Smaller, the moon has a smaller mass and a smaller radius, and thus the acceleration is smaller, right? Did that match what you were saying, Ben?
Yeah.
It sounded like you kind of answered, but I wasn't sure. I want to make sure we're on the same page. Cool. How are we doing over here? We okay? Sweet. All right. Should we keep going? Should we move on? Or are there more homework questions that you want to talk to?
Let's do Newton's.
Let's do it! Singular. Newton's law. Today we're doing the first and second law. Yeah, we'll get there. That goes into the whole story.
Not because his name, right?
Has nothing to do with his name. I don't judge people by their name. Come on. You gotta make sure. You know me better than that, right? Well, his first name. I mean, it is a little. No. Now I'm hoping that like your parents aren't like so super big Isaac Newton fans, and that's why you're. And now, as I'm like saying all this bad stuff about Isaac Newton, you're gonna be like, Mom, Miss Carmeling, blah blah blah.
Isaac was named after Adam.
Were you really? No. All right. Ladies and gentlemen, I need you to come up. We're just going to do a little demo right up here. Then I'm going to have you draw some pictures. So you need to come up here. And I need Mira. Can you go over on the other side of this space here? So if you're not sitting maybe in these, just like if you're in the back, just come this way. We're just going to do a little like a little case study with 4 situations. Your shoes are really cute. And you need to watch them so that you know what's going on. Does that make sense? So we're just roll the ball because that's really what we do, right? In physics, we just roll balls. We did that outside, we're doing it here. So I'm going to roll a ball. I want you to look at 4 different specific points, and all you need to do is stop it.
Okay.
Can you handle it?
No.
I believe in you. Come on, growth
I don't
mindset.
believe in
Can
you.
you stop the ball? Stop. All right, here we go. So situation 1 is right now, or we'll call it A. Situation A. B is when I'm pushing it. C, D. Bring it back. We'll do it again. All right. There's nothing magical in this. I mean, there's nothing unexpected. Let me say that. Okay. So there's A, B, C, D. Got it? Those are in your head? All right. We're going to go draw pictures. Thank you so much. You did a fabulous job without even believing in yourself. I'm proud of you. That's awesome. All right. So here we go. We're going to draw some pictures. Oh no, the ball just fell. All right. Don't say these things. Stop. You just like you want me to throw you out of the room. Like looking for trouble there, Jordan. My goodness. Case A. Case B. Case C. Oops, I'm drawing this backwards for you guys. I'm sorry. Shall we relabel these? Do you rather it this way or do you want it the way that you saw it? Is it okay this way? Okay, sorry. I usually have, whatever, doesn't matter. As long as it makes sense to you. All right, so there are four situations, 4 cases. I would like you to draw free body diagrams in each of those cases. In each of those situations, draw a free body diagram of the ball. So right now you're working on this. You're not doing other stuff. You're not chit-chatting. You're working on this. Everybody is writing this down. So I want everybody to be writing this down. So in each of these cases, remember you're drawing a free body diagram. A free body diagram is all of the forces acting on an object as well as the object. And in each case, the force is labeled force of blank on ball in this case, right? Force of blank on ball. So what is acting on the ball? So in the interest of time and progress, I would like for you, whether you're finished with all of your 4 situations or not, on the board, have one person please draw with the help from everybody else. This is a collaborative effort. The free body diagram for case A. Okay? So make it big, take up the whole space, draw a free body diagram for case A. So this is just in case A. All we're doing is case A.
It's not as big as the force. It's just like
All right, how are we doing? Are you ready to go? You guys ready-ish? Almost? Almost? All right, I need to see it in 5, 4, 3, 2, 1. Show me your boards. 1, 2, 1, 2, 1, 2. Yay! Everybody's got 2 forces. Malik, what's one of the forces you've got on your ball? Gravity. Which was that one? Pull. Down. And you didn't write just force of gravity, did you? You wrote something else there? Or what would you say? The force of the... Yeah. And then in parentheses, you can write FG. That's awesome. All right. And Monse, what was the other force that you said? Oh, it's frozen, so you can't see the beautiful pink arrow I just drew. Go ahead.
The force of the floor on the ball.
Which way does that one go?
Up.
Up. Awesome. The force of the floor on the ball. And we can call that a normal force. All right. All right, do case B. Go, go, go. Case B.
See what you can add.
Yeah, what's up?
Okay.
Where's that? As it gets landed.
It's the force of an object on object, right?
Perfect every time. So it's 5 force.
It's just pushing from this way, doesn't it go that way?
Or then she's being
I mean, I guess
All right. Let me see your boards.
Show me the board.
Are you not ready? Do you need a countdown? Okay, like maybe 10 seconds? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Now show me your board. All right, you got one arrow. It doesn't have any. Was that just like counted too fast?
I don't know.
Okay.
That's her answer.
All right, so I see for sure a few. So I see down, which I'm assuming is your earth force. Is that right?
Yeah.
Awesome. And then I see the normal force pushing back up. Awesome. And then I see some other forces that I'm not quite sure what they were. So show me your board again. I hope you didn't erase it because I want to see it. Force of the push on the ball. Force of carbling on the ball. Force of Miss K on the ball. I like the word F-O-K. Force applied. So you got to tell me what it is though, right? So that's the thing. There you go. The force of K on the, yeah. So I see a force going, and I'm going to call it this direction, just because that looks like the way I want it to go. So it's got to be the force of carbling or whatever. I'm going to say Miss K because I'm lazy. On the ball. You can put that that's an applied force in parentheses. That is totally legit. Okay? One piece of information that I want to make sure, because I saw this at least one time and I saw some people talking about this too. This arrow, like literally is me pushing on this side, right? But I want all of the arrows in a free body diagram to be coming from the object. So even though I'm like standing over here and pushing, I want the arrow to come from the ball. Does that make sense? Just because otherwise it gets really confusing. You're like, I don't really know what's going on. But if you have all of the forces kind of pulling from it, you can play that tug of war game really easily to see what's going on. Okay? Yes?
Okay, so we just have that one on the other side. So like on a test or quiz, how do you tell like?
So if it was just in, like if it was just kind of in a vacuum and it said, you know, Miss Carmeling pushes on a ball with 3 newtons of force, like horizontally, it would not matter which direction. The only reason I put it this way is just because like I feel like my story is going that way. That's the only reason. Yeah. Other than that, I don't care. Yeah. Does that answer your question, Stella?
Yeah. We're just saying.
Okay.
We know
Yeah.
We put friction.
Yeah. So that was the other question. I saw some people that had an extra force, a fourth force, right? The force of friction. Now, I will agree that in order for that ball to roll, you have to have friction. But for today, I'm going to say we're going to ignore the friction. And the only reason is because moving forward, I want to ignore the friction as well. So we're imagining, I don't know if I told you guys that I'm in the market for a bowling ball. I don't know if any of your families, like there's somebody in your family that has a bowling ball that it's been sitting in a closet for a million years. If you know that, and you'd be like, hey, my physics teacher really wants that bowling ball, and you could like hook me up with a bowling ball, that would be super awesome. I would very much appreciate it. No, I will not give you extra credit because that wouldn't mean anything in a standards-based grading system. But I will give you my undying appreciation. I will tell every student from here on out. I'll be like, this is so and so. You know, like I will give you props forever. We can even engrave it, right? Like this came from Mira's like uncle's closet or whatever. Yeah. Anyway, so answer is no friction from here on out. Okay. So I'm going to leave case B just like this. Given that information, for case C, I want you to draw the forces acting on the ball. What was happening in case C? It's rolling. Right, we're doing a little rawhide action. Okay, so in case C, we're saying no friction. Draw the free body diagram for me. Go.
This first one.
It's a beautiful
I think this one. I don't think that's
Are you guys ready?
There's still got to be something.
There you go.
Until it stops.
All right. Let me see it. Show me the picture.
I think it's this one. Josie wants us rowdy, so she's sad.
She's depressing.
Yeah.
Oh, sad.
Every morning.
All right, I have a question because I see, wait, hold your board up. I see 2 forces, 3 forces, 3 forces, 3 forces, 3 forces. Here's my question. Nope, don't, Josie, don't. No, because what was the ball doing, you guys? Rolling, right? Rolling. The only things that can be applying a force are objects. Now, I know why the issue is coming up. It's because I was dressed up as Ray yesterday. And you think that I have the power of the force, but I don't. That is all fake. Okay? After I let go of the ball, when it was in between me and Mira, right? So Mira was over there, I was over here. The ball was moving. Was I touching the ball? No. I had no contact with the ball, right? Was Mira touching the ball?
Not until D.
Not until D. So there was no force of carbling because I know that in the movies, it looks like the Jedi have this like ability to like raise rock. Right? It's fake. Okay? It was just rolling. The earth was pulling down, right? And the ground was pushing up. Anything else acting? No! It's just FG and FN. That's all you got. Hi. Inertia is nothing. It's nothing. We'll talk about it tomorrow. Before the bell rings, can you give me just 1 second? Because I have to tell them something real quick. Oh my gosh.
But that would mean it's in equilibrium.
Yeah. High five for you. Does not matter.
It's moving.
Here's your assignment for tomorrow. I changed it, so if you wrote it down before, it's wrong. 129, 1 and 5, 143, number 2. I know, but you love physics, so it's great. Hi, I'm so sorry.
No. I skip recording, Jones.
Sure, she was helping me. She does.
Well,
I need one thing of water. How do I get an A?
Honestly.
You see Derek Rose?